続いてのご講演は、東京大学のリーさんで、Python Deep Learning Toolkit for the, こっちは勝つな。こっち、Python the Natural Language Processing Toolkit for the Medical Text Generation よろしくお願いいたします。
Thank you so much. Today I'll be presenting this project. It's called ASCII, a Python natural language processing toolkit for medical text generation. I am currently the project research associate from the Information Technology Center at the University of Tokyo. For those who are not familiar with this field, natural language processing or NLP is a part of AI branch. So it enables computers to understand and make response to human language. Maybe most of you have been trying ChatGPTs or machine translation or some other machine learning tools or NLP tools. So this has been very important to support our daily lives. And the core techniques including general machine learning approach, deep learning approach, or the very recent popular tools, which are the large language models. This topic is mainly focusing on the medical text processing. In terms of the medical text, before computers have become popular, doctors or patients or nurses, they use manually written text to keep the records of the patients, which are really messy and unstructured and really hard to read. And then after many years, when the computer became a helpful tool, then the hospitals and doctors, they try to move everything to be more structured or well organized by using electronic health record systems. So we call this system as we call this record as EHR, which is short for electronic health record. So this kind of record contains lots of information, such as your personal information, your age, your brief medical history. And then every time you go to the system, then there will be record for your visiting. In addition to that, you may have some medical information. What kind of medicine did you take? So these kind of systems contain a lot of helpful data, especially the clinical or healthcare data. So the question became, how do we make use of these kind of data and try to make them helpful or try to get some useful knowledge or information from those data? Again, we still want to do some works based on these very sensitive or very hard to read text into something that we can understand, or we want to translate them into other languages, or we want to summarize them for the doctors to help them to read something, to read about the data from the patient more efficiently. So then the work is basically it is done for we did a tool which is the Python-based toolkit for medical text generation tasks. So we mainly focus on 4 different generation functions. These are question answering, summarization, simplification, and machine translation. In short, question answering allow you to ask a question. Imagine it's very similar with the ChatGPT. So we ask some medical question, we try to give you a response. And summarization is that if you have a very long document, then we try to summarize them in a very short and accurate way. Text simplification involves to generate understandable text we will try to make those medical terms to be easy to understand for laymen. And the last function is machine translation, which is quite straightforward. So we support, I think at least we support 12 languages. So we fine-tuned our BERT-based models to make the translation work better, specifically on this text, specifically on these clinical texts. And in this tool, we also support some other basic functions. like to recognize entities. So given a sentence, we try to recognize which word is, for example, name of the drug, or which is which entity is an organization. So such very useful basic natural language processing functions. We also support some interactions with the database, so people can do query or search very efficiently. And here I want to quickly show two evaluations. So for example, this is some most of recent models, the performance on the accuracy of answering questions. So these are, we conducted a very comprehensive evaluation on the performances of the recent bird-based models. We also conducted human evaluation on the generation tasks, and we asked two physicians to give us ratings based on different criteria. So just to validate our toolkit performance. And the tool is very easy to use, and installation is also very user-friendly. So you just go to the GitHub page and did a very simple download and installation. So for example, on the right, it shows an example of the machine translation function. So all you have to do is to input your data, and then this shows your source language is English, and then you want to translate into French. So you just call a single line of command or Python script. We're able to do this job for you. And then if you're interested in more examples and informations, feel free to search the paper, and we have a preprint version online. And also we want to thank all of the contributors, because this work is a very large and comprehensive evaluation. So we have so many other organizations to join us, including Duke NUS Medical School, Yale School of Medicine, and so on. And then in the follow-up work, because we have noticed that everything is now moving to large language models, and also some large tech companies, they try to implement or develop their own GPT-based models or large language models. And then our follow-up work is actually focused on the the generation, medical text generation tasks. So for example, we noticed that when you ask something about medical question to ChatGPT or other similar models, they sometimes generate some information which are not really accurate. So for example, some numbers it may answer in a wrong way, or some of the fact errors they may generate. So our follow-up work is actually try to improve on these generation on the generation text from the large language models to improve their factuality and trustworthiness. So then in this work, specifically, we integrated knowledge graph to make sure that the knowledge the large language model is using is very accurate. So then we also add some ranking and some other novel techniques to make sure the question answering, to make sure that we can answer questions in with more factuality. So this is a short demo that we compared with the original ChatGPT 3.5. So once we ask a medical question, sometimes GPT has no knowledge on this. And the GPT would just simply say, I don't have access, or I don't have knowledge on this. But after our improvement, because our algorithm will search from the database, and it takes some time. And after that, we can search from the evidence we can search for the evidence of the knowledge, medical knowledge databases, and then we're able to give more correct and more factual answer to specifically the medical questions. So yeah, this is the end of the talk. It's very short but brief, but also we're looking for collaborations. If you're interested, feel free to contact me offline. Now I'm happy to answer any questions. Thank you.